Hello and good day. Welcome back to our class. This is Teacher Oni de Guzman, and our topic for today is solving exponential equations for grade 11 general mathematics. So let's consider our example number 1. If I have 4 raised to x minus 3 is equal to 16. So the very first thing that we will do is we will convert 16 into exponential form such that 16 is the same as 4 squared, or 4 times 4 is equal to 16. Now that we have the same basis now, so we can equate now the exponents. So it means that x minus 3 is equal to 2. Now solving for x, so add both sides of the equation by 3. So I have here x is equal to 2 plus 3, or x is equal to 5. Now to better verify whether our answer is correct or not, I'll substitute that in the original equation such that 4 raised to x minus 3 is equal to 16. Now, I'll substitute 5 minus 3. So this is equal to 4 raised to 5 minus 3. Is it equal to 16? Solving it further, I have 4 raised to 2 is equal to 16. But 4 raised to 2 is equal to 16. So truly, 16 is equal to 16. So therefore, the value of x is equal to 5. Let's have our example number 2. So if I have 2 raised to x plus 3 is equal to 4 raised to x minus 2. So our objective is to make our bases the same. So I'll express 4 such that 4 can be expressed as 2 raised to 2. Then I have the exponents x minus 2. So I have here 2 raised to 2 times x minus 2. Now, notice that I can distribute 2 raised to x minus 2. Or, since I have now the same basis, therefore, I can equate x plus 3 is the same as 2 times x minus 2. Okay? So, now, I have now this expression or equation x plus 3 is equal to 2 times x minus 2. Therefore, I can distribute 2 times x is equal to 2x, and 2 times 2 is equal to 4, but this is minus. Now, solving for x, so I have here 3 plus 4. If I add both sides of the equation by 4 and subtract both sides of the equation by x. So therefore, I have here 3 plus 4 is equal to 2x minus x. So I can have that the value of x is equal to 7. To verify whether my answer is correct or not, I'll check that using the original equation of 2 raised to x plus 3 is equal to 4 raised to x minus 2. Substitute the value of x, which is equal to 7. So I have here 2 raised to 7 plus 3. Is it equal to raised to, or 4 raised to 7 minus 2? Simplifying it further, I have 2 raised to 10 is equal to 4 raised to 5. But 2 raised to 10 is equal to 1024, which is the same as 4 raised to 5, which is actually 10 or 1024. So therefore, x is equal to 7. Let's move on to our third example. If I have 10 raised to 3x plus 2 is equal to 0.1. Our objective is either to make our bases the same or our exponents the same. So in this particular example, we can express 0.1 as 10 raised to negative 1. So here, so 0.1, remember this is equal to 1 over 10, or this is the same as 10 raised to negative 1. Now, since I have the same basis, I can equate the expressions or the exponents 3x plus 2, which is the same as negative 1. Subtracting both sides of the equation by negative 2, so I can have now 3x is equal to negative 1 minus 2, or 3x is the same as negative 3. Dividing both sides of the equation by 3, so therefore x is equal to negative 1. Now, to verify our answer whether this one is correct or not, I'll substitute x is equal to negative 1 into the equation 10, okay, raised to 3x plus 2. So, I have here 10 raised to negative 1 plus 2, is it equal to zero point 0.1? So I have here 10 raised to negative 3 plus 2, is it equal to zero point 0.1? But then again, if I have here 10 raised to negative 1 is equal to zero point 0.1. So truly, zero point 0.1 is equal to zero point 0.1. So therefore, the value of x is equal to negative 1. Let's move on to our fourth example. So I have the expression or the equation 9 raised to 2x is the same as or equal to 27 raised to x plus 4. So notice that I have different bases. So my objective is to make the bases the same or the exponents the same. But since I can express 9 and 27 as the power of 3, so I can rewrite this 9 as 3 squared raised to 2x. Then I have 27 is the same as 3 raised to 3 raised to x plus 4. Then I can simplify, okay, 2 times 2x is equal to 4x, while 3 times x plus 4 can be, okay, I can distribute 3 as 3 times x is 3x, and 3 times 4 is equal to 12. Now, since I have now the same basis, I can have now, okay, or I can equate the exponents 4x is equal to 3x plus 12. Then, subtract both sides of the equation by 3x. So I have 4x minus 3x is equal to 12. So therefore, x is equal to 12. Now, to verify that, I'll use the value of x, which is equal to 12, into the original equation. 9 raised to 2x is equal to 27 raised to x plus 4. I can use the derived formula or derived equation as 3 squared raised to 2x is equal to 3 raised to 3 raised to x plus 4. Okay? Now, again, I'll continue the derived equations. So, since I can multiply 2 times 2x as 4x, then I'll distribute 3 to x plus 4. I have 3 times x is 3x. Then we have 3 times 4 is equal to 12. Since I have the same basis now, it is easier for me to substitute the value of x. So 4 times x is equal to 4 times 12. On the other hand, on the right-hand side, I have 3 times x, which is equal to 3 times 12 plus 12. So notice that 3 times 12 is equal to 36 plus 12, so it will result to 48. But 4 times 12 is 48 also. Now, if you will use your calculator, so you can find that the value of 3 raised to 48 is approximately 7.97 times 10 to the 22nd power. So, if you have your calculator. So, therefore, the value of x is equal to 12. So that ends our discussion about exponential equation. Again, so this is Teacher Onin Guzman. Do not forget to subscribe to my channel so that you will be notified about my new videos. Thank you.